very much for joining us, Juan. Let's drive right into data-driven right away. There's a risk here as organizations talk about being data-driven, they need the underlying tools to do that. And of course, the pressure comes on IT. And I fear a risk of, again, an explosion in complexity. It's going to be difficult for developers to create these data-driven applications and processes. There's an awful lot to do. What are we doing within Oracle to make life easier for the developer here?
Okay, thanks, Andrew. So I'm going to walk through some of the things that we're doing as part of the database team at Oracle to make the next generation of apps, which are data-driven apps, dramatically simpler. So this gets a little bit geeky, but not too much, so stick with me. So I'm going to walk through. So when we talk about data-driven apps, there's a number of things that we're working on. So we talked about machine learning, AI, things like blockchain, social graph-based applications, spatial, JSON, IoT. So I'm going to talk about how you build a data-driven app, how we make it, how we natively integrate all this technology into the database to make it dramatically simpler to develop these apps. So I'm going to go through these one by one. So let's start with machine learning. So we've heard a lot about AI and machine learning. Well, this is something we've been working on in the Oracle database team for quite a while. And our goal has been to make machine learning easy, deploying and using machine learning, making data-driven business decisions easy. So what we're doing is we're putting this technology straight into the core of the database. So we've taken over 30 in-database machine learning algorithms, including deep learning. And we use these now to make real-time recommendations, fraud detection. It's really business. What we're working on in the database is business machine learning. You've heard about kind of images and cancer. We're working on business machine learning. So we built these algorithms into the Oracle database. And you can directly call those. So database developers, application developers, can directly call those just as SQL statements. So you don't have to create a separate machine learning system, move all your data, synchronize the thing, keep it current. You just call machine learning algorithms directly in the database, in the data warehouse, in the OLTP, build the model in the data warehouse, run it in the OLTP in real time. And you can extend these algorithms also with Python and R-based algorithms that you develop outside the database. So it's something we've been working on a lot. We have a new version of our Oracle database. It's about to ship. It should ship starting next week, where we have something called AutoML, auto machine learning. Because the hard part of machine learning is figuring out how to use all these algorithms. So we've made that completely automatic, so it can predict things. It can look at data, look at outcomes in the past, and say, hey, these are the things that predict outcomes. So it'll automatically configure that. And this is something we've been working on for a while. And this whole data science, data mining, machine learning used to be a very niche application. And now it's become very mainstream. So what we've decided to do is include this for free in all our editions of our Oracle database. So we make machine learning super easy for everyone to adopt. And when we talk about machine learning, this is very sophisticated algorithms that we've been working on for over 20 years. And it's really machine learning for business data. So that's the first thing. Build machine learning natively into the database. Let's talk about another big thing. You hear a lot about blockchain technology. Again, our goal is to make using blockchain technology for these data-driven apps dramatically simple. And blockchain's all about identifying and preventing fraud. That's kind of what blockchain's all about. So we've done something very unique, very different, very innovative with blockchain. We're the first database to put blockchain technology directly into the core of the database. So with Oracle Database 20c, again, the release that will start shipping next week, we built for free something called blockchain tables. And it's super simple. You just create a table, tell me it's a blockchain table, and then as data is inserted into the table, we automatically cryptographically encrypt the data and chain the data together, which is what blockchain does. And then users can sign the data if they want to also, and the provider can sign the data. So it makes it super easy to adopt this blockchain technology in existing applications or new applications. Super easy. The blockchain tables just look like regular tables. They act like regular tables. They can participate in queries and transactions. So this takes that new generation of technology in the core of the database dramatically easy. Okay, next then, let's talk about more data-driven things. So graph analytics, social graphs. So that's another big thing now. It's like, look at the people, how they interconnect, who are the influencers, who are the dependencies, what are the communities, how do you look at people that are coordinating to create fraud? So this is a new generation of technologies that's being built into data-driven apps. And again, our goal is make this dramatically simple. So we've built over 50 parallel social graph algorithms directly into the database. Things like community detection, pathfinding, ranking, centrality, that kind of stuff. And again, you just call those with very simple APIs. You don't have to move data, create a separate database, do all that kind of stuff. And again, this is something we've had for a number of years. We keep enhancing it, and we've decided to make it free, again, make it widely available. Now that it's a common technology, it's no longer like a niche, small number of people using this. It's very common. So we made it free in all database editions. Again, making that graph technology super easy. And again, we're talking about very sophisticated algorithms that are already in use in thousands of enterprises. So this is not some vaporware or some new thing. This is very sophisticated graph algorithms. Okay, one more, spatial. It's another big thing. Everything includes some kind of spatial operation now. And again, same formula. We're making spatial really easy for the new generation of data-driven apps. So we've taken hundreds of spatial operations. So again, this is a technology we've had for many years. And what you can do with spatial technologies, in real time, you can, for example, simple thing, compute distance between places, assets, people. So you say, where's the nearest place I can buy this widget? But it goes well beyond that. You can analyze transportation, telecom networks, sales territories, marketing territories. Is it working well? Is it not working well? It's already in use by pretty much every government in the world to do land management, public safety, defense, also for analyzing satellite imagery. So it's extremely sophisticated technology that we've had for years. We keep enhancing it. And again, this has become very mainstream. It used to be very niche. Only a small number of people wanted this. Now it's very mainstream. So we've made it freely available across the entire Oracle database. So we're making it dramatically easier to build these data-driven apps. And there are hundreds of these algorithms that are in use already by thousands of enterprises, pretty much every major government in the world. Okay, another area. So we heard about the B's, IoT. IoT's Internet of Things. There's devices, manufacturing, cars, streaming data into databases. It's been a challenge to get that data into databases. So again, we're trying to make that super easy. And the way this works, it's a very simple concept, which is you take standard SQL. Instead of trying to put it straight into the database with all the ACID properties, which slows it down, we just automatically buffer the data in memory, the IoT data. A background process bulk loads it, makes it super easy, super fast to use Oracle database for IoT data. And it is super fast. You can insert 25 million data elements per second on a simple 2-socket server. And then you get the full analytic capabilities of Oracle for this IoT data. So that's yet another way we're making data-driven apps super easy. And one last thing I'm going to talk about is JSON. So JSON's very popular with developers because it allows dynamic structuring of the data. So we've been working on integrating JSON and relational for many years. And our goal is to make it so that developers can use the right format for the right use case. So for example, if you know the format of the data, you can use the standard relational column format. But for dynamic data, it's super easy now to use JSON. We've been integrating JSON into the database for several years, and the algorithms are super sophisticated. It's more sophisticated than actually pure JSON databases. And as an example of that, you can take, if you know what JSON is, you can take any JSON element and index it automatically. You can do ACID and parallel SQL across JSON and relational data. Again, super easy to take all these technologies, machine learning, spatial, social graph, IoT, JSON, integrate it directly in the database. Just call a function, you get it. You don't have to stand up a separate database. You don't have to do anything. It makes it super easy to develop these next-generation data-driven apps.
Which is exactly what we need to be able to do. So a lot of more capability, many of which was there already, as you mentioned, Juan, but being continually developed upon, and a lot more functionality for the developer. But developers are also in this world of building data-driven organizations. it's not just the tools they use, they're actually using new paradigms as well. They're developing using microservices, they're developing using event-driven programming, they're thinking about CI/CD. Do we do anything to actually help these development paradigms as well?
Yes, so right, it's not just the technology is changing, the development paradigms. So we have to support these development paradigms. If we want to make developing these data-driven apps easy, fast, and inexpensively, we have to support these things. So I'm going to walk through how we're doing some of this. So let's start with microservices. Microservices, very common development paradigm. I'm not going to explain it here. But the idea is we want to make it super easy to develop using microservices. And the way we do this is we allow each microservice to basically store its data in a logically separate database, a logically separate data container. And then we can, at the physical level, either separate or combine these logical databases to either simplify the deployment or make it more scalable and more isolated. So by using these technologies, you can use microservices in the app tier with containers and Kubernetes. In the database tier, you use pluggable database for every microservice, and it makes it dramatically easier to develop using this new microservice paradigm. And on the topic of microservice, another area we've been working very hard on is something I call data as a microservice. So treat data as if it was a microservice. So it's something that developers are very comfortable and very rapid to develop in. So it's DAAM, data as a microservice. So the idea here is actually pretty straightforward, which is you can take any SQL statement, any view, any stored procedure, and tell Oracle to automatically generate a REST interface on top of it with JSON outputs. So that's the output that the way that developers, new age developers, want to access data, using REST and using JSON. So what we do is now, with these data as a microservice, instead of using traditional database interfaces, you use a new age, very standardized REST API. You call the database using REST. And this simplifies and standardizes access to the database. Also, you can use Java or PL SQL stored procedures inside the database and call that from your microservice using REST to eliminate a lot of network round trips, which really slow down the application. And this is just like JavaScript is used in the browser. So if you're a developer, you know that use JavaScript in the browser to eliminate all these expensive round trips. You do the exact same thing with data as a microservice. So this is another area we've been focused on, a new development paradigm, which is instead of calling the traditional way to databases, treat a database as a microservice. So it's data as a microservice. OK, let's move on to events. So this is very popular, extremely popular with developers. Developers want to use something called event-driven programming. And again, I'm not going to go into the details of that, but I just want to say that our goal is to make that super simple. And there's a number of ways we're doing. So the leading event platform is Kafka. So what we're doing is we're integrating the database with the event-driven application framework. And there's a number of different ways we're doing that. For example, we can use our Golden Gate replication product. So you can take changes as they occur in the database, and we'll stream them out to Kafka and make them into events that can be consumed by other parts of the business. We can also do the opposite. So we can stream events out. Now we can also, and this is available now, query the Kafka events from the database. So we treat it as an external table. We've standardized this. You can run analytic queries inside the database against events that are in Kafka. And another thing that we're doing is integrating the Kafka events with the events that we've had in the Oracle database for years, which are called queues, advanced queues. So advanced queues are a lot like events, but they're transactional. You get ACID properties, and you get very good analytic queries on them. So we're integrating those. So what we're doing is we're integrating the APIs. So an application that's written to use Kafka to push events and pull events from Kafka, we're making it possible for that to automatically push and pull events from AQs in the database that people have been using for decades. So tightly integrating the event-driven model into the database, outgoing, incoming, and the APIs as well. Make it super easy to develop with these paradigms. And then I want to talk about SaaS. So SaaS is software as a service. That's how large apps are developed now. That's how multi-tenant apps are developed now. And this is something we put a lot of emphasis on because Oracle builds multi-tenant apps. We build our Fusion applications for ERP that are used by thousands of large enterprises around the world. We have NetSuite that's used by thousands of small enterprises, tens of thousands of small enterprises. And what we've done is we built the SaaS model directly into the database to make it super easy to develop SaaS apps. So the idea here, again, is the same kind of idea of a logical database. So when you have a SaaS app, let's say you have a financial app, you might have 10,000, 100,000 companies that are using that SaaS app. What we do in the database is we give each of these companies, each of these users, a logically separate database. So it's physically one database, but it looks and feels like a logically separate database. And this has a lot of advantage. It makes it easy to develop these SaaS apps because the tenants become completely transparent to the application. And since each tenant is in a logically separate database, you can do operations on the tenant. You can clone the data. You can back up the data for just the one tenant. You can restore the data. You can do DR on just that data. You can move that tenant from place to place. And the database enforces the tenant security. So it's no longer every piece of the app has to enforce that tenant security. And also, you can use standard tools like analytic tools against that logical database. So each tenant can run their own tools against their data. So it's a very different SaaS architecture for developing SaaS, and it's something that we've built into the database. We're already using this in NetSuite and in Fusion Apps and in Taleo, and there's a lot of other customers using it as well. And then the last thing as far as developing, continuous delivery. So again, this is something developers really want. It used to be that you develop a new version of your software, and once a year or so you ship the new version. Well, that model's in the past. Everyone wants continuous integration and delivery. You want to make the new functionality available every day, every week. So you can't have these large changes that require downtime to apply. So this is something, again, we've been working on for many years at Oracle. And the key thing here on the database side is when the app changes, those changes can't require downtime in the production application. You can't stop your airline ticketing or your bank because you want to make some change to the app. So all these changes have to come in completely online. And we've built very sophisticated functionality. We have something called edition-based redefinition, so we have multiple versions of the database schema active. We can change the format of the data completely online. I've talked about the native JSON XML, which are dynamic formats. So these are technologies that we built, and they're used by very sophisticated applications. So already, Salesforce uses this edition-based redefinition to keep their applications online while they change it. And we have many customers. They also use things like the online table redefinition. Keep the applications online, continuously roll out changes. So this eliminates this need to batch up all the changes into one downtime window a year, one downtime window a quarter. It's a big deal. So those are the ways that we're making it easy to develop using these new paradigms, things like microservices, things like CI/CD, things like events.
Absolutely.
Much better technology.
So you've been very busy, Juan. There's a lot of development in the database here. So what I've heard is that there's deep native integration. So when the request is to build the data-driven organization and to look to the tool sets to do that, don't get bolt-ons. These are being fully integrated and therefore close to the data, the very thing which is driving the whole process, exactly where you want it to be. The outcome of that, of course, is that it's easy and it's simpler, less prone to error, of course, and higher speed in development. But when I also heard that in many ways now the tool, the arsenal the developer has in building these applications nowadays is expanding it. It's not just the tool sets that we saw in the past. ML is now a tool. Blockchain is now a tool to use in my new developments. And that's being made available for free as part of this as well.
Yes, right. All these things, blockchain, ML, graph, it's all now free, included by default in the Oracle database.
You've got it there as well. Now, you may not know this actually, Juan. In fact, I don't think you do, but I'm a very keen amateur home automator. I program in Python, and I use Kafka and so on. I've got Z-Wave devices all over the house just to annoy my wife. And I noticed that there's lots of different types of data flying around. An awful lot of it is key value pair. This door's open, that window's shut. There's spatial data, as you've touched upon earlier. And I, as an amateur, but of course I know many of our customers as well, there's a temptation to look for a different data storage, a database, for these different data types. There's a temptation to do this. That can't be right, is it?
Yeah, so that's an important topic. So there's a debate in the community about this topic of, do I put my data in one place and run all my functions there, or do I use single-purpose databases for every person? So I have a machine learning database, a spatial database, a graph database. So there's a big debate that's going on. And we have a pretty strong position on this debate, as you can imagine. So I want to introduce the concept of a converged product, because that's what we're talking about here. And the analogy that I use here is a smartphone. So it used to be that if you wanted to make phone calls, you had a phone. If you want to do photos, you got a digital camera. If you want to do music, you got a musical device. So all these things and many more were separate products. And you had to buy each of them and you use them. But that's changed now. So what's happened is all these products have gone into one converged product, which is a smartphone. So they're really features of a smartphone now. And what I'm talking about here is it's the same thing happening in the data management world. So when machine learning first came out, when JSON first came out, when blockchain first came out, it came out as a completely separate product. Hey, you want blockchain, you use a entirely different blockchain system, different way of developing, different way of storing data, different way of accessing data, all proprietary. Same thing with machine learning, same thing with JSON. Hey, you need a JSON database. You can't use a regular database. But what's happened now, and what I've talked about, is these things are being converged into a converged product. So they're really features of a converged database now. And there's two giant benefits here. One is it's just a lot simpler. It's inherently simpler to have one product. It's just like one smartphone is a lot simpler than carrying 10 devices around and plugging them all in and powering them all and recharging them and all that kind of stuff. But there's a second benefit, which is a little more subtle, which is the synergy. By having all these things in one phone, like the music can now stream from the internet because it's part of one thing. You get all these benefits from combining these features into one. And the same thing happens with a converged database. If you can run machine learning and spatial and blockchain, then you get machine learning on spatial data, and you get blockchain protection of that whole thing. So you get synergies across these features by making them, putting them into one converged product. And that's where our primary focus is. Although we support special purpose databases, our primary focus is create a converged product that's much simpler, much easier to adopt, much easier for developers. So, and this is somewhere where a place where we stand in opposition in a different place from some of our competitors. So if you look at what Amazon and a lot of niche database vendors say, they say you should run a single purpose database, and almost all those are proprietary databases for each data type and workload. So it's a separate database for machine learning, for spatial, for graph, for everything. We say run a converged open database that does it all. And I'm going to talk about 2 or 3 quick benefits of this, which are mostly pretty obvious. If you think about this, this is kind of a no-brainer decision. One thing is, for developers, it's dramatically simpler to develop using a converged database. So if I have a database and I need to do some spatial operation, find this guy wants to buy this widget, where's the closest location you can get that widget? It's much simpler to just call a spatial query inside that same database than it is to stand up a separate spatial database, move all the customer data into there, move all the real-time inventory in it, keep it up to date constantly, keep it synchronized with all the other databases, manage it, do all that stuff. Much simpler, just call the spatial query in the database. So for developers, this is a no-brainer, because creating this distributed execution data movement, extremely complex. Also, on the management side, once you've created all these plethora of specialized databases, you kind of have a nightmare going forward. So every step is simple. You say, oh yeah, I need spatial, let me just stand up this guy. Oh, I need machine learning, let's do it. I need JSON, let's do this. Oh, I need graph, let's do that. Every time you take that step, it's a simple step. But now you have to manage these for the rest of your life. You have to make them all highly available, secure, scalable. Every one of them is different. Everyone manages different. Everyone secures different. The models are different. It's a nightmare for IT. So we stand pretty clearly on this, that it's much simpler on the converged database side, and that's what we're working on. Now, some people say, well, this isn't open.
I was going to say that one.
Okay.
This isn't open. The flip side of the coin, of course, is when you start talking about having one management environment, et cetera, and being converged. The flip side is often that's associated with being a closed system. You're going to try and trap me into that. Surely we're not going to do that.
Right. So you got to look at what's really open and what's really closed, right? So Amazon, for example, is a big proponent of this single-purpose database. The trouble is, all the databases that they develop, Redshift, Dynamo, all the rest of them, they only run on Amazon. If you want to run them on premises, nope. If you want to run them in the Oracle Cloud, nope. If you want to run them on Microsoft Cloud, nope. None of that. It's completely proprietary. Whereas the Oracle database will run everywhere. It'll run on Amazon, it'll run on Azure, it'll run on-prem, it'll run everywhere. And the other key thing is, Oracle's based on open standards. So we've always been based on open standards. Things like SQL, Java, REST, JSON. It's completely open standards based. You look at what Amazon does. They start with an open source product. They close it, and then they add all these proprietary interfaces. So my example there is if you use DynamoDB, something they talk a lot about, completely proprietary APIs. Once you've written your application of that, you've written to their APIs, their data models, their transaction models, their indexing models. You're stuck. That application can't run anywhere else. And it requires a complete rewrite of the application to run it everywhere else. If you use Oracle with open standard SQL, you can run it anywhere you want. It's much more open.
So one pretty compelling arguments for supporting the creation of data-driven platforms. And of course, again, a compelling argument for converging that data and avoiding pain in the future.